In 2012, a neural network beat second place by 11 percentage point. The gap is why every model you use today exists. You'll trace the 5-step chain from there to ChatGPT. Last video, we talked about parameters, what it means when a model has 70 billion of them. Today, we are going to see how those numbers got that large. But first, let's go back to when they were small, when they barely existed. In 2012, the best computer vision systems didn't learn from the data. They were handcrafted. Researchers wrote explicit rules, things like if a pixel edge goes at this angle and the picture appears nearby or the texture appears nearby, call it a cat. This was called feature engineering. It required domain experts working for months to recognize a single type of object. And the error rate, the best result anyone had achieved that year in the world's biggest image classification competition was 26.2%, meaning 1 in 4 images wrong. That was considered good. The runner up 26.2%. That's not an improvement, that's a different game. 11-point gap in a field where meaningful progress meant 0.3% per year. Here's what made it different. And this is the part most people get wrong when they tell this story. It wasn't architecture, neural networks, convolution layers. Those ideas had existed since the 1980s. Jan LeCun was demonstrating them on handwritten digits in 1989. But they were expensive, they didn't scale, and they couldn't compete with handcrafted methods on real world data. What Krzyzewski, Susker, and Hinton did differently, they used a GPU, a graphics card, the kind designed for rendering video game environments, because those require millions of parallel calculations every frame. A neural network training pass is also millions of parallel calculation. The hardware fit the math perfectly, and nobody had seriously tried it at scale. That insight was a new equation. It was a new tool called applied to an old equation. And the 6 years of this approach is theoretically interesting but practically useless ended in one competition on one weekend. What happens next? Because once AlexNet proved the recipe worked, everyone started cooking. In 2013, Google publishes Word to Vector. Instead of teaching machines to see, this teaches them to read, turning words into vectors in a high dimensional space where, and I want you to pass insert with this, king minus man plus woman equals queen. Language now has geometry. You can do arithmetic on meaning. In 2014, Ian Goodfellow invents the GAN, two neural networks in a competition. One generates fake data, one discriminates real from fake. They train each other. The generator gets better at fooling, the discriminator gets better at detecting. The result, photorealistic images generated from nothing. Also 2014, sequence to sequence model. The architecture behind early machine translation. One sequence of tokens in, a different sequence out. The mechanism that will eventually become the transformer. In 2015, ResNet, 150 layers deep. Top 5 years on ImageNet, 4.49%. Human performance on that benchmark is approximately 5%. 3 years later, after AlexNet, machines can classify image more accurately than people. Now, does that mean an AI was solved in 2015? You might think so. It wasn't. Image classification is one narrow task on one curated dataset. The bigger machinery, open-ended languages, reasoning, generalization to novel situations still hadn't clicked. They were signals, but not the destination. March 2016, Seoul. DeepMind's AlphaGo is about to play 18 times world champion Lee Sedol in a 5-game match. I want you to predict something before I tell you the result. Go has more possible board positions than atoms in the observable universe. At that time, computer could barely beat an amateur player with significant handicaps. The consensus among Go experts before the match, AlphaGo had no championship against a world champion. Many said it would take another decades. Pause the video here for 2 seconds and predict the outcome. AlphaGo won 4-1. Not barely. In Game 2, Move 37, a move no professional human player ever had played, one that commenter initially called a mistake, turned out to be the creative stroke that Lee Sedol said he had never considered. The machine has developed intuition the world's best human didn't. Here's where it clicks. This was a different kind of intelligence claim. Not the model recognized a pattern it hadn't seen in the training. A move that had never been played by humans in a game with more positions than atoms was the correct move. The movement changed how the publisher and researchers understood what the systems were becoming. June 2017, 8 researchers at Google published a paper titled Attention is All You Need. It introduces the transformer architecture, 100 million parameters, designed to make machine translation faster by removing sequential processing. RNN, the dominant architecture at the time, processed one word at a time. The transformer could process an entire sentence simultaneously, which made it parallelizable, which made it scalable. Here's the part most people miss. They weren't trying to build the foundation of modern AI, they were trying to solve a translation bottleneck. But ChatGPT, Claude, Gemini, every major language model in the production today is a transformer variant. One architecture, one paper, one team, one translation problem. The scalability they unlocked is the reason the parameter race you're about to see was possible. GPT-1 2018, 117 million parameters. GPT-2 2019, 1.5 billion parameters, 13 times larger in 1 year. OpenAI was so worried about the misuse, they released it in stages over months. GPT-3 June 2020, 175 billion parameters, 117 times larger than GPT-2 in just 2 years. 350 gigabytes just to store. Training estimated at tens of millions of dollars. Context window just 2048 tokens. The pattern: transformer architecture plus scale equals emergent capability. Capabilities that weren't explicitly programmed appeared at certain scale. Few shot learning, analogy, basic reasoning. Things nobody instructed GPT-3 to do it. It just could because it had seen enough of the world. Last video, we talked about bigger isn't always better. Here's a specific window when bigger absolutely was better. 2018 to 2020. Every doubling of parameters in the transformer era unlocks something qualitatively new, not just quantitatively improved. November 30, 2022. OpenAI releases ChatGPT as a free research preview. Built on ChatGPT 3.5, fine-tuned with reinforcement learning from human feedback. You could type to it like a person and it answered like one. 1 million users, 5 days. 100 million users, 60 days. The fastest consumer app to hit the milestone in the history. Here's what those 12 years add up to. 5 ideas in a sequence, parallel compute, representation learning, scale, attention, alignment. Every model name, every company, every benchmark you read about it is a variation on those type of 5. Learn those 5 and the history stops feeling like a random list of breakthroughs. Next, we are going to look at what makes AI fundamentally different from every piece of software that came before it. The shift from deterministic functions to probabilistic models, and why that changes everything about how you build, debug, and trust the system.